Okay. I am recording the class as usual so that I can save it, upload it in my channel. You can watch it again and again. It will help you, right? Number two, other two sections who are taking the class in remotely. So I want to be consistent across them. So that's the reason I adopt these policies. So that, and I purposely make all the exam in online so that everyone get equal shot. Okay, I send an email tonight by saying that any question, if you copy and paste it in any artificial intelligence, DeepSeek or ChatGPT, any other, I already put those and get the answer. You understand, right? So that means in the syllabus, it is very clearly said, any use of artificial intelligence will automatically earn F. I will not listen anyone. Clearly, I'm telling you. And you have seen, I did not give you a lot of materials, right? I give you just one PDF document and enough time and said that these are the basics of all statistics I covered. And asked you watch the video again and again. So you fundamentally you will see 7 multiple choice questions, 7 or 6 yes no questions, 6 is written response, 2 sentences. Altogether, how many minutes? 30 minutes. So yes no question you can answer in 10 seconds, 5 seconds, 12 seconds. Multiple choice maybe 1 minute maximum. So, and that means you will get to answer 6 written response around 15 minutes. Okay. Why I make it 30 minutes? Because so that you can heavily prepare on your materials. The 11-page document that I gave you, you should prepare heavily on that by underwriting, by highlighting what does this means, what is that, multiple choice questions that I made, and the watch and the video. If I give you unlimited time, like 2 hours, it does not make sense, right? So 2 hours usually I make when this is the in-class exam and a lot of computational things, no multiple choice, no yes, no. Understand? Things has been changed, so I have changed myself. Okay. So today we are going to learn what? R programming. Okay. And then next class also R programming, and week 2, 3, 4 will involve R programming. And then all of the code I will provide, you will use this code to do your project. All codes will be given, and you are allowed to use this code in the upcoming exam, which will have a lot of computations, like how to compute binomial probability by writing all of these things. But if you write a 1 line of code, you will immediately get. Okay. You need to understand the theory, you need to understand the rationale, and then without now computer and software, you cannot do anything, right? If you get a job after graduation, your company will give you a desk, chair, and a computer. If you ask them, buy for me 80 TI-84 calculator, then you think, what? TI-84 calculator? What are you going to do with the TI-84 calculator? You understand? But 50 years ago, you have to ask your manager, can I get a TI-84 calculator? No, right? So computer and software. Okay. With this introduction, let me directly go to R. R is a free software which was developed in Auckland, New Zealand in 1991 and 92, something like this. What is interpreter-based language? Interpreter-based language means, let me open the R. If I open the R, are you seeing console is written in there, right? Console. Console means in this case, if you write here 3 minus 1, you will get 2. So console means any type of code you will write, it will immediately give you the result like the way you write in your calculator. But before coming up with this interpreter-based language, there was a language, C++, and Java was developed 1998, and then SAS. Those are compiler-based, 3 windows, editor, compile, and output. Okay, those are compiler-based. But these are interpreter-based. Interpreter-based means if you have these things, you have everything. Okay, you are a super programmer. You do not need an editor. Do not need to go there. Just write everything in there, and you get the result. That is the interpreter-based language. And Python was developed in the same period in Netherlands. Okay, so Python and R are the highest, have the highest user. Actually, Python has the highest user. Okay, if you take such other courses with me, you will also learn Python. The materials that you are learning today, you will also learn these things. If you take with me like R programming or some other biostatistics course in the second semester or summer. Clear, right? So you understand what is R? R is a interpreter based language. Okay. Like the way first exam material I have provided, also like project material. Let me open the project material. This is the computation by R. This project material I already uploaded in the Canvas. Okay. Did you have a chance to take a look at that? So there are 30 problems. Okay. I am going through all of these 30 problems. How to compute this by using R. Okay. Step by step, very slowly, all 30 problems. After finishing these things, if I have some time, I'll go for the real data analysis. Okay. After finishing this 30 problems. Are you with me? Any question? Comments?
Said you already opened them.
Yeah, it's in the Canvas. Okay, so I may not publish it. So that's the reason. Go there, and that's the reason I did not publish it. Okay, now go there and go in here. And this is the modules. And this is published. This is already published. Let me see whether that one is been published or not. Modules. It is now published, okay? Can you see it or not? Now you can see it. Ready, right? Okay, take a look at that. I have put here module 2. Actually, it should be module 2, week 2 to week 4. So I will update it, okay? So in this module 2, all the things that you are going to learn is R programming, which you are going to use for your project, okay? Which you are going to use for your project. Okay, so let me start. Let me open a Word file, blank Word file I open, and insert multiple pages. Multiple pages I have open. So now let me go to there. So this is the document where I will start. Okay. So you know there is a function, how to compute a function. Okay. First function is what? Fx equal to 5x plus 10. Are you seeing that? Fx equal to 5x plus 10, right? 5x plus 10. How can we evaluate this function when x equal to 1, x equal to 2, x equal to 3, up until x equal to 10? Okay, so take a look the R code. You understand, right? I am going to evaluate a function. So A, B, C, one argument, two argument, three argument. A is the argument of X, B has two argument X and Y, C has three argument X, Y, and Z. Understand, right? I want to evaluate this function when X, Y, and Z has certain values. Okay. So let me directly go there. My R, there is a R, there is a R studio. R studio is always better. Why? Because do you want to close this? No. Take a look at that. This is, let me maximize these things. Why it is not getting maximized? Okay, so I think edit. How to make the things bigger. It should be clear console word count, find previous, go to line, folding, paste. There is a some way, let me see view. Okay, I think I have to check it later. But can you see it or not? Can you see it or not? Can you see it or not? Okay. You cannot? You can see it, right? There is a way to make it bigger. I don't know how. Profile tool. No, not tool. I think it's in the view. But when I put the view, actual size, zoom in, zoom in. So control plus equal. Let me see. Control plus equal. Control. Okay, now it is little better, right? Okay. Now our first question was what? First question was, I want to evaluate this function. Take a look at that. I want to evaluate this function fx equal to fx f of x that equal to 5x plus 10. Okay, so if I plug x equal to 1, then we are getting 5 times 1 plus 10, which is equal to 15. If I plug x equal to 2, then we are getting 5 times 2 plus 10, which will give us 20, right? So this way, if I plug x equal to 10, then what we will have in here? 50 plus 10, which is 5x, right? So 50 plus 10 equal to 60, right? Right? This is the answer. So how can I do these things in writing the code? So I give a name foo1. Foo means function 1. You can give any name in there, but name must be contain a letter. It should start with the letter. You cannot put 1, 2, 3. 1, 2, 3 could not. A function name must start with a character. So if you put, I want to write the function as 1, 2, 3. No. Understand, right? Understand, right? I write foo1, that means function 1. If you do not like it, you can put your girlfriend name in there. That's okay. You understand, right? So I put here foo1 and then I am putting function of x. This is a function of argument x. And then I am putting curly braces and then I am writing the function 5x times 5x plus 10. Okay. So in this case, when you see this, in R, when you see this sign, when you see this sign, this means equal. Understand? Like less than and a dash means equal. That less than and dash means equal. Understand? So that means equal. This means equal. So here I write here 5x. I write 5x plus 10 and I put the result, storing the result in R, and then I want the return of the R. Understand? So let me again telling you these things. I write the function 5x plus 10 and store it in R. R is any name. If you do not like R, you can put here X, you can put here Y, you can put here Z, but it must be a name with character. Okay, and then I want the return of it. So that is why in order to get the return, you have to write R again. Understand? You have question?
Not yet.
Not yet. So you are understanding. So now I just want to run these things. Okay, control enter. Okay, now if I want to write here, foo1 is my function, right? Foo1, I want to put there 1 and see the result. And then I want to put here foo2, I get the result. I want to foo10, I got the result 60. If I want all of them together, I just want to write 1 to 10. Okay, and then I'm getting all the results. Are you seeing? So now anyone ask you to write the code to evaluate a function, you can do this, right? Just this simple code, right? Gentlemen, are you okay? Are you okay? right? Now, similarly, for the second function, which has the argument of x and y, I write foo2, you can put any num, x, y, z. Function is a keyword, you have to always write function in there. And then x, comma, y. After writing x, comma, y, you can write r is a name where I'm storing the function. This function is storing. And this part, if you do not like, okay, let me remove these things. Take a look at what I am removing. I want to remove this and plug it by equal sign. Okay, that's okay. Okay, if you do not like that thing, you can remove these things, because in Python it is always equal sign. You can do these things. Now see, I want to run this function. Control enter, the functions run, right? It has a two argument, right? Now I want to write here foo2, and I want to put here suppose 5 comma 7, x equal to 5 and y equal to 7, and see the results. Are you understanding? So we have learned how to write functions and evaluate the values of the function for different values of the arguments x, y, z. Okay, now if you want to evaluate them at once, just run the line number 15. Line number 15 I am running. So this is the all values. Everyone is okay? So in your project, if I ask you evaluate a function with 4 arguments, you can write it, right? I have shown you how to write function for up to 3 arguments. And then if I ask you in a project, evaluate the function for, like, it has a 4 argument, w, x, y, z. And then similarly, this is the 3 function argument. 3 function argument, we can do these things. Okay, we can do this. Similarly, 3 function argument, we can do this. Now let me show you the third function. It is phi. It is phi times e of x minus 17y plus log of z. Okay, phi is what? What is the area of a circle? 3.141. Phi is a number that how phi come into an existence. Can any one of you tell me? This is the phi. This is the phi, which stands for 3.141 something. Is continue, okay? How it was discovered, and why should we believe it? If this is the type of question, if someone asks you, how can you answer? You understand? What is phi? How it come into existence? Where did it come from? Why do we need it? If there is no phi in the world, what will be the problem? You understand? So phi comes actually from here. If this is a circle, okay, it is a circle, and this circle has a, this is called diameter, okay? If diameter, half of diameter equal to radius, right? Half of diameter, then 2 radius equal to diameter, right? So 2, if this is equal to 1, if this is equal to 1, okay, so if length of a diameter equal to 1, then the circumference of this equal to 2 phi r. Okay, then see 2 phi equal to what? 1, right? And then phi, right? Right? 2 r equal to 1 times phi, right? So phi equal to what? 3.141. Go to the home, take 1 meter of a diameter, take a look there. Go to the home. Are you seeing what I'm? Go to the home, take a 1 meter diameter, 1 centimeter of diameter, okay, and then make a circle over there. After making circle, keep the circle and measure it by the tape. You will see it will be 3.141. Understand? That is why it come into an existence. That is why it come into an existence. Without these phi, many computations would not be able. The area of a circle you cannot compute phi r square. Okay, so that's the way phi come into an existence. Okay, so you have seen this is the third arguments function xyz, and then xyz is in there. Now I again I name it foo3 function x comma y comma z r, and then phi uh, times exponentiation of x. So okay, let me see. Do you know how this come into an existence? E to the power x. This is called exponentiation, right? E to the power x. How? So it is a definition. Understand how? This is 1 plus x over factorial 1, x square over factorial 2, x cube over factorial 3, x4 over factorial 4. That way it will continue. Now, if you plug x equal to 1, then x equal to 1, if you plug 1 plus 1 over factorial 1, 1 square over factorial 2, 1 cube over factorial 3, and it will continue like this way. Now, if you plug here 2, then it should be 2. It should be 2 square. It should be 2 cube. It will be 2 to the power 4 divided by factorial 4. It will continue like that way. So this is the definition. This is the definition. Definition. Remember, this is a definition. Definition. Do not be confused. E to the power x, it was defined like that way. Why? The answer is why. Why someone defined like this? Why they are making our life is so complicated by defining this? Do you understand the question? Anything comes to your life, immediately pose a question, why this? And that way you will learn deeply. If you learn deeply, then you will motivate yourself. Okay, now I learn these things. So the reason this come into an existence e to the power x, when there was a big number, people come up with a definition of a logarithm. Okay, so logarithm definition is what? This is the definition of the logarithm. Log of e to the power x equal to y. So this means e to the power y equal to x. This is the definition of logarithm. Okay, this is the definition of logarithm. Understand? Now give you real life example. I am giving you explanation why e to the power x. Understand? Why e to the power x? Why the mathematician defined e to the power x? I am giving you that explanation. In order to understand these things, now I have provided you the definition of log. Log e to the power x equal to y and e to the power y equal to x. What does this mean? This means if there is a log 2 over 32, then the meaning is 5. Log a to the power 32 equal to 5. If you don't believe me, let me quickly take you to the r. So if you write here log 32 comma 2 and you see 5. Are you seeing? Are you seeing? Log 2 to the power 32 equal to 5. Okay, this is what I write here. Log 2 to the power 32 equal to 5. What is the meaning? Meaning is that if you write 2 to the power 5, then you will get 32. That's the way it defined, and they have come up with the logarithm. Understand? Logarithm is used in order to make big number small. Understand? So then people are telling around the world, well, so then what we should want a logarithm that will known as the natural log, and everywhere in the world people will know that this is the natural logarithm. So in order to do that, they come up with a number. That number is e to the power x. Do you understand now? Why e to the power x? Why we need it? Why they have defined it? Without e to the power x, will there be any problem in the world? E to the power x, they have defined. Otherwise, there is many logarithm on different bases. log 2 base, log 3 base, log 10 base, like 100 base. You understand, right? Okay. They said that many logarithm will have different kinds of bases. We want to come up with a base that will be known rest of the world, which is natural log. In order to define natural log, they have introduced a new definition, which is e to the power x. E to the power x definitions you have understand. Okay. Now I think I have provided you a lot of foundational thing. Okay. So now what we have learned from the question 1, we have learned how to code, how to write our code to evaluate a function. Understand? What we have learned? We have learned how to write our code to evaluate a function. Understand? Any function, anyone, your younger brother, elder brother, mother, father, whoever come to you, ask you, I have this complicated function, I want to evaluate it for the 10 different value, just follow the procedure. Okay, that way all functions is done. Okay, after doing functions, now we know there is a linear equation 3x plus 5, right? What is the value of the x? And then B, C, D are the quadratic equation, x square minus twice x plus 1, x square plus 4x plus 3, 4x square minus 3x plus 19 equal to 0. Okay, these are the quadratic equation, and the first one is a linear equation. How can we solve these equation? By using software R. Understand? By using software R. This is what now we are going to learn. In order to learn that, let me directly take you to this second problem, question number 2. So our first equation is 3x plus 5 equal to 0. If you take the 5 other side of the equal sign, then it will be negative 5, right? So I put here solve 3 comma 5, then it will be the answer. Okay. Okay. Now the other part. Now the quadratic equation part. Okay. So in order to do the quadratic equation, let me take you to a document, blank document. You know, if there is the equation like ax square plus bx plus c equal to 0, then how can you compute? How can you solve these equations? This is the solutions of the equation. Square root of b square minus 4ac divided by twice a. This is the equation. This is the solution of any quadratic equation. When an equation is said to be quadratic, if it has a square term, x is unknown, a, b, c are known, a, b, c are given numbers. Okay, are you understanding? So the question is, suppose I want to write it in this format. I want to write this 9x square 3x plus 6 equal to 0. What value of x I should plug in there so that it will be 0? That is the question. A quadratic equation. Are you understanding? Quadratic equation. So 9x square plus 3x plus 6. This is the equation. In this equation, 9 is known, right? 9 is just a number. And then 3 is another number, 6 is another number. What is unknown? X, right? How can we find the value of x? What value of x I should plug so that I will get 0? Right hand side is 0, right? Right side is 0, right? Yeah. Left side must be 0. What value of x? That is the solution of the x. Understand? And how can we solve this? By using R. Understand? How can I solve this? By using R. So if I give you a problem in your project like this, you will follow the code that I'm going to show you now. Okay? So take a look at that. I have to program these things. This is the one part and this is the other part. These are the things I am going to solve. So take a look at that. If anyone struggle with my class, have office hour with me. Okay, email me and we can meet by team or we can meet physically in during during the office hour that I will provide. Take a look at that. I am writing a function that have a 3 argument a, b, c. Why? Because you remember ax square plus bx plus c. There was a 3 argument, right? A, B, C. So that is why I am writing a function, line number 29. I am writing a function that have a 3 argument A, B, C. Okay. After that, I am writing b square minus 4ac. B square minus 4ac. Your question is why you have written these things, b square minus 4ac. My answer is this is the solution. Where is that one? B square minus 4ac. Are you seeing that? This is the solution, b square minus 4ac. So I write here b square minus 4ac, b square minus 4ac. Okay. Now see, this b square minus 4ac could be positive. Okay, let me show you. These things could be positive greater than 0. These things could be 0. And these things could be negative, right? Are you understanding? Suppose b equal to 7. So then 7 times 7 equal to what? 49. And a equal to suppose 6 and c equal to 10. Then b square minus 4 ac would be negative number. So I want to say that b square minus 4ac could be one of the three. It could be greater than 0. It could be equal to 0. It could be less than 0. And I am going to put these 3 conditions and want to compute the solution like exactly these things. Exactly these things I want to compute. Okay. So you do not need to understand a lot of theory, but you need to understand the code. If code, my responsibility is to teach you, train you on how to write the code and what part explain what. Okay, take a look at that now. I have written one function in there. The function is known as the foo. This function I am going to use within another function, foo2. Okay, take a look at that, what I am doing. Take a look at that. Now foo2 is a function of ABC. If foo1 ABC greater than 0, then solution is x1 equal to this and x2 equal to this. Why one negative, one positive? Because take a look at that. Here positive, here negative, right? One positive, one negative, right? So that is why I put here one positive, one negative, and this is the negative is in this equation. So, and then result is this. X1 and X2 is the result, return the result. This is if, else if foo, that means this first function equal to 0, then the solution is this. See, if, else if, else. Otherwise, there is no real root. That is the answer. Okay. Remember, here student, let me say you like that. Let me address. Here student, listen. Understand these out of difficult data. If, else if, else. 3 conditions are used. Certainly, sometimes in your life, you need to use 5, 6 conditions. If the diabetes level is this, then that. If diabetes, else if diabetes level is this, then that. Else if diabetes level is this, that means glucose level is this, then that. Else if, and then finally else. Are you understanding? Are you understanding? Let me spend few more seconds, few more moments in here. In this case, in this line of code, I am evaluating a function under 3 conditions where I put here if, and then I put here else if, and then I put here else. Suppose you have a data, that data has a variable glucose level, okay? A variable glucose level. From this glucose level, you are creating another variable. If glucose level greater than 30, you can put here if, then it is a high risk. you can put here level 1. Else if glucose level between 250 to 300, then it is 2. Else if glucose level 200 to 250, then 4. From the quantitative glucose level variable, you are creating a categorical variable by putting if, else if, and else conditions. Are you understanding? Are you understanding? So why we have to do these things? So come in here. In this case, this could be greater than 0. This could be less than 0. This could be exactly equal to 0. There are three things, right? Either negative number or positive number or 0. Nothing else, right? So three conditions we put there and evaluated. Now the function has been written. Function has been written. All the functions has been written, then we will solve one after another all equations. So I have run all of this. Control enter. Control enter. Okay. There is a basic R, there is a R studio. I am using R studio. Understand? Okay. So any of you struggle with me, please have an appointment with me. I am open. Even we can. I respond email. Last night I respond email at 10:30. Okay. I do research. I do teaching. I have two beautiful daughters. I have a very fun, good time with them. Okay. And I also have a crazy wife, but loving. I whatever I have, I'm happy. Everything is so good, so nice for me. Okay, the reason is that I have free time. I can give you time. Okay, but please take this course seriously. Stick with me. Give time. Give efforts. Ultimately, it will be paid off. You will learn a lot of statistics. How to do all the computation by using software. Okay, if you write in your resume, you have a advanced level efficiency or intermediate level in the R, you will have better chance of getting interview compared to if you write, I know Excel. It's like grandfather levels guy is applying for the job. Understand, right? Okay, so now I run these things. Now take a look at that. My entire code has been run. Now I will go and plug the value one after another. Foo2 is the function which is producing the result. I will plug the value of ABC. Just I will plug the value of ABC. I want to write here foo2. See, foo1 was created and has been used inside foo2. So take a look at that. Foo1 has been created and it has been used inside foo2. Foo1 and then foo1 and then else. Okay. Foo1 has been used inside foo2. So now I am going to get the value of ABC from the equation. Okay. Here our A equal to 1, B equal to -2, C equal to 1, right? So let me plug it in there. 1, -2, and 1. Our answer is 1. It has only one solution, which is equal x equal to 1. Okay. Now I want to do again. I want to go 1, 4, 3. I want to put 1, 4, 3. Let me put 1, 4, 3. 1, 4, and 3. This is the result. It has two solutions. Two solutions means x equal to either -1 or x equal to either -3. Now I want to solve for the third one, which is equal to 4, -3, 19. 4, -3, 19. 4, -3, and 19. There is no real root. Okay. Do you understand these things? What does this mean? A negative number under a square root. A negative number under a square root. What is the name of it? It is known as a complex number or imaginary number. Imaginary number, complex number or imaginary number. Okay. So that is why they said there is no real root. Are you seeing there is no real root? Because under that square sum, there is a negative number coming. Okay. Okay. Before going to the next one, let me again tell you one thing. The code that you have learned, remember these things. When you will do research, when you will do work with a large data, you have a data set, a variable, you need to transfer it to another variable, then if, else if, and else condition would be used. So else if you can use multiple times. If, else if, else if, else if, else if, and then finally else. So finally else means he ignored previous all and come up with the remaining one. Okay. Okay, after this, now I want to do some matrix. Do you know what is matrix is? Okay, let me show you what is matrix is. You definitely know these things, right? You definitely know these things. 2x1, 3x2, 5x3 equal to 9. Okay, and then you can put here 9x1, 5x2, and then 3x3 equal to 12. Okay, and then you can put here 2x1, 3x2, and then 5x3 equal to 13. These are what? Linear equations, right? Equations. And I want to solve what is the value of x1, x2, x3 from these three equations. Understand? So this equation can be written like this way. Take a look at that. How am I writing? 2, 3, 5, 9, 5, 3, 2, 3, 5. So I write like this way. And then I write here like this way. x1, x2, x3. And then I can write here 9, 12, and 13. Understand? Now I want to show you. If you multiply, take a look at that. Let me take a bigger one. Let me take a bigger one. Draw size. I want to take the bigger one. Maybe, okay, this one is fine. If you multiply this with that, 2x1. Okay? Understand? If you multiply this with that, 3x2, right? If you multiply this and that, then this is called the 5x3, right? Equal to this 9. So this equation can be written in matrix format in this way. This is a 3 by 3 matrix, 3 by 3 matrix, 3 row, 3 column. This is a 3 by 1 matrix, 3 row, 1 column. This is a 3 by 1 matrix, 3 row and 1 column. Are you understanding? So this is called the matrix A. Okay, matrix A, which is a 3 by 3 times this is a matrix X, which is a 3 by 1, and this is the matrix of number. You can put here AX equal to maybe some number N. You can put here something like that. So that means these big equation are expressed in just AX equal to N. Are you understanding? So X is called a matrix. Understand? X is called matrix. Understand? So X is called matrix. If a matrix has a equal number of rows and columns, that means 3 rows, 3 columns, 4 rows, 4 columns, equal number of rows and columns, that matrix is known as square matrix. Understand? If a matrix has equal number of rows and column, that matrix is called square matrix. Okay. On the other hand, if the matrix does not have the equal number of rows and column, those matrices are called rectangular matrix. It has a 3 row 1 column. It has a 3 row 1 column. So you understand what is matrix is. I have a plan to cover a lot of materials in this course so that your foundation should be very solid, very strong. Okay, so that next courses that you will take will not be that hard for you after you understanding basics of all statistics. Okay, so you understand what is matrix is, right? So now I have two matrices. How can we multiply two matrices? I want to multiply matrix A with matrix B. I want to multiply this matrix with that matrix. Okay. I want to subtract this matrix from that matrix. I want to add these two matrices. This is what I have written. Like addition of matrices, subtraction of matrices, multiplication of matrices, determinants of matrices, inverse of a matrices. If there is a number 7, inverse of it 1/7, right? So there is a matrix. How can we find the inverse of a matrix? Why we need this? We need inverse of a matrix in lot of scenarios, especially when we conduct regressions coefficient estimates. Okay. And then what is the rank? Rank, like how many rows are independent, how many rows are not independent, which I'm going to discuss now, and how to change column to the rows and rows to the column, known as the transpose of a matrix. Okay. So let me conduct these operations by using R. Ready? Ready? Okay. Let me take you to R now. Okay. Here is the way you can write a matrix. Control Enter. You will see. If you write here A, this is your matrix. Okay. Now, if you write these things again, run this is Control Enter. This is your matrix B. Okay. So now if you write here B. Okay. Now, how can we add? Add is just this. Two matrix I want to add. So 16. Are you seeing 9 plus 9? 9 plus 7 equal to 16, right? Here is 16. Okay. It is pointwise. Last one, if you see 4 plus 5 equal to 9. 4 plus 5 equal to 9. Okay. Last one. Are you seeing that? Are you okay? You're understanding, right? Okay. So now this is the subtraction. This is the subtraction. Okay. Now in order to multiplication, I have to explain these things to you, how these things is done, how this multiplication is done. You multiply this with that plus this with that plus this with that, and then add them, you will get the first element. So 9 times 7 equal to 63, 5 times 7 equal to 35, 35 plus 63 will give you 35, 98, 98, and then 4, you have 102. Here is 102. Are you seeing that? So let me explain these things to you. Let me write it. Let me write it, then you will understand. So how can I get the first element? 92. You have to multiply this with that, which is 63. You have to multiply this with that, which is equal to 35. And then add, you have to multiply this with that, which is equal to 4. Then if you add them, you will get 102, and you will see 102. Are you seeing 102? That's the way multiplication takes place. So if I, in the project, if I give two matrices with 5 rows and 5 columns, you will follow this thing. Understand? Matrix multiplication, lot of applications in real life. Okay, determinants means what? What is the value of the matrix? That is known as the determinants. So the determinants could be obtained. Determinants can only be obtained for the square matrices. So which is like if a matrix like this way, let me write it in here. 2, 3, 1, 4, 1, 9, 5, 6, 2. What is the determinant of this matrix? If you take the 2, that means 2 you have taken. So this and that cancel out. You have 1 times 2 minus 54. Now you will take this one 3. Then this and that cancel out. 4 times 2 equal to 8. 5 times 9 equal to 45. Plus, if you take the 1, then what will happen? 24 minus 5. That's the way. Determinant is obtained. Okay. So in the R, you can just write these things, determinants, you will get it. Okay. And then how to find the inverse of a matrix? Solve. That is the inverse of a matrix. Okay. Now what is rank? Let me explain these things to you. What is rank? What is rank of a matrix? I need to explain this thing. That is a very important. What is rank? What is rank of a matrix? So suppose this is the matrix A, which is element 2, 4, 3, which is equal to 4, 8, 6, 1, 9, 7. This is the matrix 3 by 3. But remember that if you multiply the first column by 2, then you are getting the second column. Right? If you multiply the first column by 2, then you will get the second column, right? So that means one column depends on the another column, right? Okay? If there is a linear dependency, that means one column can be obtained from the another column. See, the word linear dependency, linear. Multiplication, addition, subtraction, and division. Okay? Linear operator is used. If one column depends on the another column, or if one row depends on the another row, then that column does not have a full rank matrix. In this case, rank of A equal to 2. That means 2 columns are independent. The third one is not independent. Do you understand? Do you understand? That means one depends on the another. One could be obtained from the another. If you divide the second column by 2, you are getting the first column, right? So that means one depends on the other. In such a cases, it has a rank 2. It doesn't matter whether it is rows or column. If they depends one on the other, so that means it is not of the full rank. On the other hand, by linear operations, by doing linear transformations, if you linear transformations, if you do not get one column from the another column, if you do not get one row from the another row, then that matrix is said to have full rank. Then that matrix is said to have full rank. Understand? So for example, this matrix, if I write here, if I write here 3, 2, 1, 5, 7, 9, 3, 9, 6. Okay, you will not get one from the another. One row cannot be obtained from the another row by addition, subtraction, division, and multiplications by using linear operator. Okay, so you understand what is rank is. So what is transpose? Okay, let me run the code. So for example, rank of A equal to 3. And then this is the transpose of a matrix. Transpose means if, take a look at that, A, oh, this is my original A, 754. So this row become column in here, 754, 985. This is a row 985. This is a row 274. This is the column 274. Transpose mean rows would be converted to column. That is known as the transpose of the matrix. Okay. Now I purposely created a matrix that is dependent and I want to compute. Previously when I run the rank, so this one I run this rank, this is full rank. See, rank is 3. So matrix A has rank 3. So that means none of those 3 rows or 3 columns has any kind of dependency among them, among their columns and rows. Okay. Now I created this matrix. After creating this matrix, I created a rank equal to 2. So are you saying this matrix has a rank 2? Because the second column could be obtained from the first column. 7 times 2 equal to 14, 9 times 2 equal to 18, and 2 times 2 equal to 4. That is the rank of this. Okay. So now I created a rectangular matrix. P is a rectangular matrix. P and Q are two rectangular matrix. P is a rectangular matrix and Q is a rectangular matrix. P has 3 rows and 2 columns and Q have 2 rows and 3 columns. Okay. So now how can we multiply this? In order to conduct multiplication on rectangular matrix, one matrix number of rows must be equal to the other matrix number of columns. Otherwise, rectangular matrix multiplication is not possible. Understand what I said? You can, of the same order, of the same dimension. So if there is a two matrix which are square matrix but have the same dimension, like 5 by 5, you can easily multiply them. But in order to multiply two rectangular matrices, they must have, the one matrix should have the number of column equal to the number of rows for the other matrix. Otherwise, you cannot conduct multiplication for the, you cannot conduct multiplications for the rectangular matrix. Okay. So here is the multiplication. Here is the multiplication by 9. Here is how to create a diagonal matrix. A matrix is said to be diagonal if all the elements are found in the diagonal line and off diagonal elements are 0. Then that matrix is said to have diagonal elements, or that matrix is called diagonal matrix. How can you create a matrix with all elements as 1? You have to create like this way. 1, 3 by 3. That means 3 row, 3 column. You can create like this way. How can you create a matrix with zeros? This is the way you can matrix with zeros. Sometimes you need to create matrix with zeros. Okay. Okay. Now I want to solve equations. Previously, we solved quadratic and linear equations. Now I want to solve system of linear equations. Are you understanding what I said? Two equations, x and y. For example, problem number 8, A. Problem number 8a, if you take a look at that, it has 3x plus 4y equal to 5 and 7x minus 3y equal to 7, right? So I want to get the value of x and y. Okay, I want to get the value of x and y for the problem 8a. How can we solve this? When we are student, we solve paper and pencil approach, right? So how can we solve these things? Let me go there. Suppose the equation is 2x plus 5y equal to 7. Another equation is x plus 7y equal to 10. Okay, this is the way. How can we get? There are two equations. There are two equations. There are two unknown x and y. There are two unknowns and two equations. There are two unknown for the two equations. How can we solve this? So when we are 7th grade, we are exposed to this type of equation to solve when we are in 7th grade. See, let me show you. First equation is 2x plus 5y equal to 7. Second equation x 7y. If I multiply it by 2, then 2x, and then there is a 14y, then there is a 20, right? Then if I subtract this and that, this is cancelled out. 5y minus 14y. So that means there is a 9, right? 9y, right? And then there is a minus 13, right? And then y equal to what? Y equal to 13 over 9. This is the answer. If I plug now y equal to 13 over 9 in here, in this equation, I will get the x value, right? That's the way we solve it when we are 7th grade. But how can we use these things to solve using R? So this is the matrix. This is the another matrix. So take a look at A. This is my A. And this is my B. Okay. So 3, 4. Take a look at the 3, 4. Where I got 3, 4. Are you seeing 3 and 4 and then 5 and 7 and negative 3 and 7, right? This is the number I have written like 3, 4, 7, negative 4, 5 and 7. After writing these things, I need to install a package which is this. Do you want to restart prior to installation? No. They'll install a lot of things now. Package matlib is in use and will not be installed. Okay, so that means I already used it. So now I want to do the library thing. That's fine. Now I want to show the equations. There are equations. Their equation. Let me see if it is in there. Why equations is not shown in there? Okay, this equation. Let me go there. If I go there, it will be shown in there. Here. Control R. Shown equation. Okay. Control R, Control R, Control. This is the hub. We are in Mississippi. Which one is the closest? I think Missouri is the closest. Yeah, Missouri is it is the mirror. Like where there is a hub, are all like 20,000 packages are in there. So after doing these things, now I want to do now this one. After doing this, then I want to show the equation. Okay, after showing the equation, I want to, okay, after showing the equation, now I want to show their plot. Control enter. Here is the plot of the two equations. Okay. After plotting the two equations, now I want to see their values, which could be obtained by using this. So x1 equal to 43 over 37, x2 equal to 14 over 37. Right? So in the project, I will give you maybe 50 to 60 questions on different data sets, different problems. But I will make sure that code I have provided. Problem will be different, data set will be different, but code will be different. Code will be the same, but the problem will be different, okay? How many of you learning R for the first time? Oh, so 4 of you. So you know already some R. Little bit. You also know a little bit of R. Okay. So give some time on this, okay? After the exam, give some time on this, and then like if you spend couple of hours, it will be easy. And R and Python is the same. Just a little bit of syntax difference. It's tiny bit of difference. Okay, so now the solution is this. Similarly, for the big one, when there is a three equations, this is the solution. Okay, so B, this is the problem. Are you seeing this is the problem? The three equations, three unknown x, y, z, which could be solved by using this. You just write the three equations like their matrix and their right hand side value 87, 77, 13 and solve. In that way, you will get the solution. When solve is written, there is a package, some package was written. On that package, they are using to give the results. Okay. Hidden, someone else already write the packages. Okay. Okay. So now I want to find the sum of first 100 numbers. These are easy thing. Let me think little bit. Now the problem number 9 is telling you how to sum 100 numbers 1 to 100. So problem number 9, I declare 100 number 1 to 100. Okay, this is the 100 number. If you write here x, this is the 100 number. Okay, then just write sum. Then just write sum. So easy, right? So if you do not believe me, let me show you. 1 to 5. 1 to 5, right? And then I write here sum 1 to 5. 15, right? If you don't believe, 5 plus 4 equal to 9. 9 plus 3 equal to 12. 12 plus 2 equal to 14. 14 plus 1 equal to 15, right? Like, what are you doing here? 1 plus 2 plus 3 plus 4 plus 5. Right? This is what you are doing. So someone wrote the code for sum inside. So I am using their keyword. Okay. So now I want to find the sum of squares of 100 number, which is this. Which is this. Sum of squares of first 100 numbers. Okay. So if you want just three number, sum 1, 2, 3, and then I want to put their square. Let me see whether it will work. If it not work, 3, right? So 14. 3 times 3 equal to 9. 2 times 2 equal to 4. 9 plus 4 equal to 13. 13 plus 1 equal to 14, right? What I did, I just took the first three numbers and squared them, add them. So that means my formula is working very good. Are you liking it? you are learning art. So do you like it? So I'll give you a big project, 50-60 problem. The reason is that your responsibility is to read all the documents that I'm providing, find the code, and plug it in your project. That's it. Then you are doing two things. One, you are learning from my lectures, and then you now know how to copy it from your problems. So that is double training will give you a good coder. Okay. Ultimately, if you go for the further study, for graduate study, for research, this is the thing you need. And when I'll do the data analysis and data mining, that will have around 80 problems. You will see big data. I'm doing a lot of things, graphing, looping, lot of things I'm doing. Okay. So that is why I keep here 3 weeks so that I can go slowly and you can learn. Okay. Now I want to do this one, uh, um, sum of deviation from mean. What does this mean? So if you take a look at that, this is the deviation, right? Each xi and their mean is subtracted and then I'm summing over. I'm summing over, okay? I'm summing over. So now this is what is always 0. This is always 0. How? Let me show you why this is always 0. So I said this is always 0. Sum of xi minus x bar is always 0. Theoretically, it is true. If you sum of xi and minus sum of x bar, and then you will see sum of xi, this is equal to n x bar, and this is equal to n x bar. Okay, this cancels, so this is equal to 0. Okay, why? Because this equal to n, and this is just a constant, and x bar is written sum of xi over n. Okay, so these things is always 0. Sum of deviations measured from mean is always 0. Okay. Okay, now after doing this, now I want to go for the 12, problem number 12. This is sum of square deviations. Sum of square division is this. So that means you are, x is already declared. What is x? X equal to this number, okay? X equal to this number. 1 to 100 is the number x. Okay, and then I want to do what? I want to do I want to take the divisions square and then summing them. Okay, this is the problem number 12. Now come problem number 13. I want to do these things. I cube plus 4 I square, where I takes value 1 to 100. Let us declare first I equal to 1 to 100. Take a look at it. If I write here I, if I write here I, if I write here I, this is the all 100 numbers. I equal to all 100 numbers. And then if I do like this, this is the all of this. So what are you learning? How to conduct summation of big numbers in a series. Remember, in a series. This is what you've learned. So now come to the next one. This is also another series, but previously it was like a summative series, and this is now summations, but there is also some part that divides. Okay, so this is the other one. Sum, but 2 to the power I divided by I plus 3 to the power I divided by I square. This is the 14. That's the way you will get the results. Okay. Yes. Here, this one. Yeah. Here, you want to put this I in the bracket? Okay, let me check. So he wants to try these things. Sum wants to put 2 and then put here I like this.
No, no, not that. The second one, the one right. Not the one, the other one.
The line number 140. Or,
Same equation.
or same one.
So you can take out the
Hold on, let me erase these things. So you are talking about line number 144. Which one I should take out? You want me to divide these?
yes.
No, I don't think so. So see, previously it was same, see? No difference. Same. Now, when I write this code at home, okay, I checked it multiple times. I mean, many of them I check manually for the small scale. So let me compute these things for the 3 numbers to check. Okay. Because this class is recorded also all of this material in my YouTube channel in different versions. If someone says something, you understand, right? So I checked it before coming in here. Okay. But anyway, I understand your frustration. Should I put a bracket or not? So it's all right. Okay. Now next one, 15, question number 15. Take a look at that. In 15, what we need to do. Uh, in question number 15, so I we are going to put I equal to 1, then there is a positive 1, negative 1 and positive 1 cancel out, then e to the power 0, e to the power 0 equal to 1. So first one is 1 over 11, and second one is e to the power 1 over 12, and then third one is e to the power negative 2 over if you put a 313 this way. Okay, so that's the reason it has been written like this way: negative I equal to 1 and 1 plus 1 equal to 0. So e to the power 0 divided by this. So this is also not that difficult. Okay. Now the question number 16. Question number 16 is telling you question number 16 is telling you you have to pick 100 values where xi takes 100 values from random integer 0 to 999. Okay, 0 to 999. How can I take 100 numbers? So we need to learn how to take the sample. Okay, so take a look at that. Xi takes 100 values from 0 to 999. First of all, we have to learn how to take x 100 values from 0 to 999. Okay. Okay. What does this mean? What does this mean? Line number 152, set dot seed equal to 50. What does that mean? No idea, right? Line number 152, set dot seed. if you take randomly some number, second time if you pick, will you get the same number or not? No, right? Fantastic. In a box, suppose there are 100 balls. You close your eyes, you pick balls, suppose 5 balls you pick. And then you return it. You think if you take again, you will get the exactly same ball? No, right? Very little chance or no chance, right? So set of seed means whatever you will take, if the same set of seed you will use, you will get the same. Understand now? Okay, let me explain these things to you. In a box, suppose there are 1000 marbles, right? 1000 small, you know a small marble, right? In a box, there are 1000 marbles. You just mix it up, close your eyes, pick in a handful of marbles. Suppose you got 10 marbles of different colors. Okay? You write it down like this. And then you put it back, mix it. Again, you take the 10 marbles. Do you think you will get the same? No, right? From the 1000. So how to get the same marble again and again? State of seed is needed. Understand now? How to get the same thing again and again? State dot seed is needed. Understand now? Understand? Do you understand now?
Would that be the same,
Same sample will come again and again.
we just repeat same sample to that?
Yeah, exactly. With that number 50. If you first time take a sample of size 100 with set dot seed equal to 50, wherever you will go, you do not like USA, you want to live in like the Ukraine or Russia or India, if you use the R and set dot seed, you'll get the same. And even if you go to the Mars and want to live there with the computer and R in there, set dot seed, you will get the same. So that is why when the researcher is doing research, it's the random thing, and when the research articles are submitted for publications, they ask that, well, you take the random sample, please provide us the seed and provide us your R code so that we can examine before publishing it. There was a Nobel laureate, not one, at least 2 Nobel laureate, who after getting their Nobel Prize, they rejected their publications. Do you understand what I said? If you search it in Google, you will find it. Nobel laureate who rejected their research article because they published it, they thought it may be true, but now they become famous and people are scrutinizing him very seriously. Okay, so that is one piece of advice I always give to the people. Throughout your life, try to be honest. That price is uncomparable, not comparable to anything. Truthfulness, honesty is the criteria that will make you different from the other. You understand? There is a very good professor at Georgia Tech, because I had a master degree from there in quantitative finance. He completed his PhD from Cornell and joined there. During that time, he published the paper, and now he is the third largest person, third faculty in the entire Georgia Institute of Technology. He is making more than around 600,000, something like that. He even made more money than the football coach, become famous. Because he reached that famous level, other people started his research portfolio and the publications that he made during his PhD. Now they are using the same data, the same simulations they conducted, and they complain to the American financial institutions, this publication is fake. It is fake. So the more higher you will reach, more scrutiny will take place because it is your early stage. One piece of advice, try to be honest. You do not know down the road, 20 years, 30 years later, for what office you are running. You do not know what hidden criteria, hidden quality you have. It will be exposed gradually, one after another. Understand? Nobody thought that Obama will become president in 2008. In 2004, I was just completed my 1 year of my faculty back home in my country. And he was invited for a keynote speaker in John Kerry's DNC, Democratic National Convention. You understand? You are just a novice senator. One speech makes difference. It can happen in your life. You understand? You are asked to go to the Mississippi capital. You give some talk. People like you. They can give you immediately very good position. But please maintain truthfulness and honesty in your life. Okay. So set dot sit means it will give you again and again. For example, take a look at that. I take a sample of this. Control enter. Now see xi x x underscore I. See, this is the data coming, right? This is the data coming, right? Did you see the data coming? Now I want to show you another thing now. See, this data will not come without running the set.seed. If I again run the line number 154, line number 153, we will not get the same thing. See, I'm running the line number one. I'm running the line number 153 again. And now I want to write it x underscore I. Now see, first one was 367. Now first one is 470. Different, right? Now last one was 765. Last one is 154. Okay. Now I want to run set.seed again. I want to do set.seed again with 50. Okay. And then I want to run this now again. And then I want to do it x underscore I. 367, right? 367, 10. Come here. 367, 10, 8. So you understand what is set.c. Set.c, right? So if you want to do the random experiment, and in the random experiment, maybe one sample give you the result which you are looking for which you are exhausting yourself. You understand? For a sample, you are spending days and night in your lab. Okay? Sleepless night. And then you are drinking coffee after coffee. One sample that you have generated, that will give you desired result. Please make sure set.seed is in there. If you want to prove something, then you have to prove it generalization. Okay. If I want to disprove it, I just need to do one counter example. That is enough. That means your case is not generalized. You understand the argument, right? In order to generalize the thing, you have to prove it under different scenarios, different conditions, case 1, case 2, case 3. In order to disprove it, if I just put one counter argument, that's it. So I hope you understand what is set.set is. You understand, right? Set.set. If you do, wherever you will go, if you want to take sample by using this and use the same seed, then it will give you the result. But if you put here 51 instead of 50 or 49 or 2000 or 1 million, result will be different. Understanding? You can take maybe 5 minutes break. Let me drink some water.
ঈশান, ঈশান, জোরে জোরে কান্না করো। এই যে আমি ভিডিও করতেছি তোমার কান্নাটা। দেখি দেখি তোমাকে কান্না করলে কেমন লাগে দেখি তো। দেখি একটু কান্না করো। হ্যাঁ হ্যাঁ, তুমি কান্না করতেছো না ঢং করতেছো? কোনটা? কান্না কিভাবে করে? এভাবে কান্না করে? আর ঢং করে কিভাবে? স্মাইল করে কিভাবে?
Okay. So after that, I selected a random sample of size 100 uh, from 0 to 999 with replacement true. See the code I have written in here. Here I am taking a sample of size 100, from 0 to 999, replacement true. That means same number can come again and again. Okay. And then after taking that, then I am doing this summing. Okay. Then I'm doing this summing. This is the answer. So I hope you understand this line of code, right? Replace means the same number can come again and again. If you do not want replace true, if replace false, if you put, then you see, I put here replace equal to F. Replace F. On the line number 153, I put replace F false. Now all numbers will be unique number. X underscore I. Now if you take, none of this coming in here like more than one times. Each is coming is unique. Okay. But previously when I write, so let me previously that one, right? If I put here true, then write here, then put here table X underscore I. Let me see if I can find one list. Yeah, see 827 is coming two times. 800 coming two times. Okay, 800 is coming two times. Table means will create your frequency table. Okay. After 16, now I want to discuss about this. I want to create this type of sequence. See, question number 17 is creating a sequence. 1 plus 2 over 3 plus 2 over 3 times 4 over 5, and then 2 over 3, 4 over 5, 6 over 7. So that means they are jumping by 2. Understanding? 2, 4, 6, 8. This is jumping by 2. How can I create this type of sequence in R and then add them all? Clear, right? So see the R code that we consider in here. There is a function called mass which we run, and then we run this. In this way, let me explain this line of code. I am creating a sequence. Take a look at that. SEQ means sequence. Sequence 2 to 38. 2 to 38 by 2. This is the sequence will be created in the numerator, and this is the sequence will be created in the denominator, and this will be the fractions. Okay, the fractions. I want to create fractions like so 2, and then denominator is 3. And then again 4, denominator is 5. 6, denominator is 7. That could be done by writing this. Fractions, then you are writing sequences. Clear, right? So sequences 2 to 38, and it will be a jump of 2. Okay. Now we have to add them, right? We have to add them. Add how? There is a way to add them. There is a addition, but before additions, each previous term will be multiplicated with the present term. So this is the previous term will be multiplied by the present term. Previous terms will be multiplied by the present term. Previous terms will be multiplied by the present time. Okay, so that could be done by known as the CAM product. CAM product means cumulative product. See, we have written the sequence in here. After writing this sequence, which is exactly like this, and then I'm doing cumulative product. Cumulative product and fractions. If I write like this way, take a look at that. Now this is the cumulative product. So here 2 over 3, and then next one is 8 over 15. How? 8 over 15. So this times that 8 over 15, these two. Okay. And if you go there, 48 over 105. So this is what the next one is. Okay. This is what this with that one. That is the way all products goes up. And then finally we just need to sum them up. So after this exam, which will be due by Sunday, spend some time on each of these 30 problems. Okay. Spend actually quite a bit of time. Okay. If you have a plan of some lazy time to spend, do not do this, just spend in there. So this is the way you make your foundation very strong. Okay. Then this part thing, if you understand, then you will enjoy the next one, then enjoy the next one. The rest of the part is easier compared to this one. There is a lot of summation, single loop, double loop. Clear? Spend some time on these 30 problems. So, and then I just need to sum them up. This is the sum of results. Okay. This is the sum of results. So you have learned how to create a sequence. Okay. And then how to add them together. Question number 18 is asking you, okay, question number 18, take a look at that. In this question number 18, if you want me to write, I can write it in here. These are independent terms, numerator and denominator. How? Sum there is a one sum and there is another sum. First sum I 1 to 20. 1 to 20. And second sum j equal to 1 to 5. J equal to 1 to 5. I equal to 1 to 20. J equal to 1 to 5. Then I have in here I to the power 4. I to the power 4. 3 plus j. 3 plus j. Okay. Now take a look at that. These are independent. I can write here sum I goes 1 to 20. I to the power 4. Then I can write another one. J goes 1 to 5. J goes 1 to 5. 3 plus j. This is one term and that is one term because they are independent, right? One does not depend on the other. Clear? Clear? Looks like you have a question. No, right? This is two independent, right? This is one term I to the power 4, but so I brought every I to the power 4 inside the sum of the I brought z inside the sum of the z. So now if we multiply them and add them, then it will work. If we add them and then multiply, it will work. Okay. And then if we want to go to the code, that is the code. In this case, are you saying one sum? Why? This is a one sum. This is a one sum and that is another sum. Okay. This is the one sum and that is another sum. Clear, right? So take a look at that. You could ask me question why there is a 4. Because if you put z equal to 1, then it will start from 4. And then z equal to 5, it will go to the 8. So that is why 4 to 8. That is why 4 to 8. Understand? No? Okay. So your question is why 4 to 8 in here, right? In this case, if you put j equal to 1, then what are you getting? And if you put here j equal to 5, then what are you getting? So in the denominator, it is 4 to 8, right? So that is why 4 to 8, 1 over 4 to 8. Understand now? So now if you run it, you will get the result. Okay. So now there is a double loop that we are going to use now. For this one, I need to spend some time in here. Draw. Okay, take a look at that. This one, what is this one? J goes 1 to I and I goes 1 to 10, right? So if you want me to write these things, how can I write it? If I plug here I equal to 1, then what I get? I equal to 1, then I get j equal to 1 to 1. I equal to 1, 3 plus 1 times j. Then if I plug I equal to 2, j goes 1 to 2. J goes 1 to 2. Then I equal to 2, right? Then 2 to the power 4. It is 1 to the power 4 divided by 3 plus 2 to j. And then if we continue in here, j equal to 10, I equal to 10, then you will get j goes 1 to 10, then 10 to the power 4, 3 plus j equal to 10. Sorry, I equal to 10 to the j, right? You understand? If I sum over I, are you understanding what I said? Here is a two sum, I and j, right? So I sum over the I plug I equal to 1, I got these things. If I plug I equal to 1, I got that one. I to the power 4 divided by 3 plus 1 times j. If I plug I equal to 2, I got j equal to 1 to 2, 2 to the power 4, 3 plus 2 times j. If I plug I equal to 10, j equal to 1 to 10, 10 to the power 4 divided by 3 plus 10 times j, right? Now what you have to do? You just need to sum, right? So this is one option that will take a lot of time. But there is a double loop options. double loop. Double loop can make the things much easier. Loop within loop. Okay? Loop within loop, that will be much easier. So this is what now I am going to discuss. See, how many? 1 line, 2 line, 3 line, 4 line. And then this is the answer calling. Total equal to 0. So that means currently I do not have anything. I will compute the sum and keep storing in the total. So first I declare on the line number 169, I declare total equal to 0. Okay. You went to the apple garden, you do not have any apple. Okay. But when you start picking the apple, one after another apple is coming, right? So that means first time you do not have anything. Now see, for I take value 1 to 10 on the line number 171. Please take a look at the board. Please take a look at the board. I in 1 to 10. For means for loop, looping. Okay. For loop 171 line number for I in 1 to 20. And then I'm putting curly braces. And within that loop, I am declaring another loop for j in 1 to I. Right? In my original sum, j is 1 to I, right? So they are taking first I value and plugging in the j, and then total, they are computing total plus I to the power 4 divided by 3 plus I times j. And this total, that one, this total is the original one, 161. And then we are putting everything in there, total. Okay. So then here, total. Okay. Now, if you run this, that is the answer. Do you want me to re-explain these things? Looks like you are lost maybe. So double looping, take a look at that. First of all, you went to the apple garden, you do not have any apple, right? That is why I declare you have a 0. Now you are running for loop I equal to 1 to 10, and within each I have a j goes 1 to I. J goes 1 to I. If I equal to 1, j equal to 1 to 1. If I equal to 2, j equal to 1 to 2. If I equal to 3, j equal to 1 to 3. Right? After doing these things, now I am writing total equal to total. This total is originally that one. Okay? This one is originally that one. And then I am writing the equations I to the power 4 plus 3 plus I times j. And then after doing these things, everything has been put in this total. That total is saved outside of the loop. Outside of the loop, that total is saved. Now I want to print the total, that way I'm getting the results. In this way, you have learned double loop, for loop, double. Clear, right? Remember, as many of you do not have a very good solid math or statistics or programming background, I am giving you every material from the very scratch. And the project problems is coming similar, but all the code I will provide or I already have provided. Understand? But the code that I am providing, if you do not go through these things, do not understand that thing, then you would not be able to do your project. Okay? If you spend some time in this week, the next class, you will understand more. And then third class, you understand more deeply. And then after third class, I will assign the project. Okay? Then you have entire time up until the end of the semester to finish the project. Okay? Part by part, you can finish it. And then from the fifth class, I will start doing the probability stuff. Okay, so now you understand these things because how to write loop within loop. This is what called the double loop. Okay. After this, now come the next one. How to do this is easy. I have to declare 1 to 1000 number and finding the sum of this. Okay, finding the sum of this. Okay. After this, now how can you compute these things? How can you compute these things now? So in this case, there are two unknown x and n. Okay. There are two unknown x and n. I want to evaluate these things when n equal to 10 and x equal to 10. Okay. When n equal to 10 and x equal to 10. So x equal to 10 means it will stop when x to the power 10 over 10. Okay. So x equal to stop when n equal to 10. So n 10, x equal to 10. So that means they will go and stop in there. So for example, if x equal to 10, then here 10, 10 square, 10 cube, 10 to the power 4, 10 to the power 5, until 10 to the power 10, right? Because n can take up to 10. So this is the way you have to write this. So if you write a function, a small function, take a look at that. There are two unknown x and y. I write a function x comma n, sum 1 plus sum. Why 1? Because of that 1. This 1, this 1, I have to write here 1. Okay. And then sum x to the power 1 to n divided by 1 to n. So this is the way, and then I can write f. I can write here 10, and then I can write here 10. Okay. I can write here 10. So what I did here, I just write a function. Take a look. I just write a function in here. Sum, because there is a summation. So that is a 1 plus sum x to the power 1 to n divided by 1 to n. So the sequence that is going in the numerator, exactly same sequence, actually is same sequence in the number of terms. Number of terms is the same, so we have to write like that way. Now, if we go like this way, this is the answer. Okay. Okay, now I want to this function. See how to construct this function. When x less equal to 0, the value is this. When x equal to 0 to 2, I have this value. When x greater equal to 2, I have this value. Okay. So how can we evaluate these things? So in order to evaluate these things, write a function. The name of the function should be temp fn, which takes a single argument x. This function should return the vector of values of the function fx evaluated at the values in x. Hence, plot the function fx for -3 to +3. So I want to take value only -3 to +3. This function, I want to, how can you plot a function? You should have a x and you have a fx, right? Otherwise, so x value -3 to +3 and -3 to +3, you will have to generate a number of fx value. X and fx, by combining them, you can create a plot, right? So X value is -3 to +3. So let us go and generate those value first. Here is the X value. I am generating 100 X value TMP. This is the 100 value that I have generated of such. See, I just put -3 to +3 length of 100. I am creating a sequence of 100 numbers from -3 to +3. Okay. I am creating a I'm creating a sequence of 100 numbers from -3 to +3. After creating this, now I want to tell you the function. The function is a conditional three-step function. That means three different fx value. One fx equal to this. Fx equal to this when x less than 0. Fx equal to x plus 3 when x is 0 to 2. Fx equal to x square plus 4x minus 7 when x greater equal to 2. Okay. So these three, how can I do this? Is so beautiful function I have written in here. When, see, I have written function x, if else x less than 0, then functional value x square plus twice x plus 3. Take a look. X square plus twice x plus 3, right? If x less than 3, then evaluate this. If else means two condition. If else means either this or that. If else. Okay. In the first if else, in this if else, if this, and then another if else, less equal to 2, I got this. Otherwise that. Okay, I think I need to explain these things to you more. First, if else, I write a conditions. If else means if this, then that, else, again another if else. If else within if else, because there are three conditions, right? So two if else means three conditions. In the function, there are three expressions, right? Three expressions. So two if else means three conditions, three expressions. So now I want to do plotting of them. So here is the plot. Anytime if you put one if else, that means two conditions you are coding for if else, two conditions. But if there are two if else, that means three conditions. So we have a functions that has a three expression, less than 0 and greater than 2 and between 0 and 2. You remember that, right? But those x value must be -3 to +3. So I generated -3 to +3 on the line number 197. On the line number 197, I have generated 100 numbers. Now, first, if else x less than 0, the functional value is x square plus twice x plus 3. And then if else go to the another if else when x less than 2, then it will be x plus 3. Otherwise, when x greater equal to 2, then x square plus 4x minus 7. Under these three conditions has been created, the value has been created. Now see, how am I plotting? Temp, which is the data, 100 data, temp, fn, temp, that means the functions. Within that function, I am plugging all the temp value and I want a line plot. Type L, L stands for line, okay? The type L, that stands for line. I think if I put here dot, it will give you the dot. Let me see. Type line. If type dot, dot is not taking. No, dot is not taking. There is another name that I forgot. Line. Dash. How can I put the dot? No, dot is not taking. The color is not, it will not take. Line plot, line taking, but they are not taking the dot on. Okay. Now come to the question number 23. We already did the 23 problem, right? See, second one, second sum, like S takes value 1 to R and R takes value 1 to N. Here I am not specifying any number. It could be a function of N and R. So for different values of N, write a loop within a loop for the following function in order to compute these things. Okay. So now, if I want to use in here, I have written it is a function of N. S1 equal to 0, R takes 1 to N and S takes 1 to R. So like the way we did the double loop. Then S1 is the initial 0, then S2 square, which is S is a looping value. If you take a look at that, this is the S and S also take the value. So that is why I put here S. Here S is S plus S square divided by 10 plus 4 times R to the power 3. So now if I want to put here like this, so that's the way you can compute it. So overall, I want to mention in here, even if it is like in this format, I have written it as a function of n, only one argument. Because if I define the n, then r takes value, the s takes the highest value of r. So r takes 1 to n. So if I put here 10, then that means r equal to 1 to 10. If I plug r equal to 1, then that means 1. Then r equal to 10, so that means 10. So one argument is enough. Rest of them will come from there. So that is why I put a argument of n, then r takes 1 to n and x takes 1 to r. Then it has been written in the format of S1, S2, r. And finally, I just declare the value of the n. So if I put here n equal to 10, I got this result. Let me write just these things instead of A1 and A2. If I run this, this is the result. But if I take n equal to 100, this is the result. If I take n equal to 1000, this is the results. If I take n equal to like this is the results. So it is taking a lot of time because there is now 10,000. Okay, so if I go there now, 100,000, and you will see it will take maybe 2 minutes because they are looping all the times. It will take maybe, because it takes 6, 7 seconds, and it will take maybe 2 to 3 minutes. It's computing, okay? The loop one value they are taking and summing and storing it, then another one is taking, summing and storing it, and in this way they will do all of these things for 1,000, 100,000 times, and then finally add them together. Now everybody in the world, like in the 70s or 80s, in all over the world, maybe altogether 500 programmers all over the world. US top university like the Berkeley, Stanford, they have a programmer. And then the physics, math, statistics people who do PhD, they go to the programmer for their things. Understand? And now everybody is a programmer. Why? Because of documents. If you write in the Google, I learned R, I took a course in PhD, but Python, whatever I learned, R, I just myself converted. Solely taking help from Google from 2017, 18, 19. By 19, I converted all my R code to Python code. It will take few minutes. I'll kill it. In order to kill it, if you just hit on the stop, are you seeing stop in there? Are you seeing stop in there? In this stop, if you hit, then it will stop, okay? I want to wait maybe 2 more minutes, and I have 6, 7 problems. I think I would be able to finish it. Let me see how long will it take. Come, not that long. I want to wait 1 more minute. Hmm. Okay, I have to kill it. Now it is 16. I killed it. Okay, so let me, what I can do, I can run it in R. Control, I want to run it in a basic R. And then I want to write it found A. And let's see how long will it take in here. And I want to go there and work in here. Okay, it is done now. Now the question number 24, 25, 26, 27, I think. Yeah, this is telling you, is telling you how to create a sequence. Okay, how to create a sequence. So here we are creating a sequence of 100 x's and 100 y's randomly from numbers 0 to 0 to 999. Create two vectors x and y by randomly selecting 100 numbers with replacement from 0, 1 to up to 999. Let x equal to this and y equal to this. Compute the following. So following thing we want to compute. Following thing we want to compute, we want to create a sequence like this, okay? We want to create a sequence like this. Come in here. So again, see, set dot seed, I have run it in here. And after running this, set.sit, I run this. After running this, I created a sample of size 100 from 0 to 999 with replacement. That means same number can come. And again, I want to create another seed for suppose that one, control, control V, and I want to put here suppose sample seed equal to 51. And then I want to run this 51 and generated that. So X was generated from random seed 50, Y is generated from random seed 51. Okay. So now how to create this sequence? Sequence is Y2 minus X1. Then it will continue X Y2 to Yn and then Xn minus 1 because it is started 2, second one. So that means first Y1 is not, so that means here I am beginning with the second one. So that means here it would not include all like up to n. So in order to make this type of things, we have to make some kind of subtraction in there. So subtraction is first y1 is missing and last x is missing. So that is why I have written in here y, that y generated. So take a look at that y. This is y, and then I do not want to consider first one. If I just run these things, control, if I write here y minus 1, all the y except first ones, take a look at that. 850 is appearing, this one is not coming because I deleted this one. Okay, I deleted that one. So this means, that means I am taking y2 to y100, and this means I am taking x1 to x99 because that one is the 100 one which I am deleting. So this is the way first sequence has been created as mentioned in here. This is the first sequence has been created in here. First sequence is created in here. Okay, now come 25, which is the second sequence. Second one is created sin y1, y2, yn minus 1, y1, y2, yn minus 1, and then cos x2, cos x3, cos xn. So now that one has been created like this way. After that creations, this one has been created. Okay, this is the way all sequences for numbers in this format are created. If you want to take a look x1, 2x2 and x3, it started at x1 and finishes at x3. Similarly, it starts at x and minus 2, x minus 1 and n. Exact same way you have to create it. So in order to create that, you have to create, see, here x, they are excluding this one. So This is sine 1 is fine. So x this one and 2x that, because 2x2, 2x, and then if this has been written in there 1 and 250, and then finally here c 1 comma 2, and this will like create like the way sequence needs to be created. These are the all positions that are mentioned in there. Okay, these are the positions that are mentioned in there. So x1, 2x2, and x3. So similarly, this one e to the power xi plus 1 divided by xi plus 10. Okay, so this one is that. Okay, finally, I want to create a matrix that will have 6 rows and 10 columns. And these elements of this matrix are chosen from 1 to 10. 1 to 10. So take a look at that, how the matrix is created. I want to make a seed.seed, a matrix is created, sample of size, sample and the size of 60. So it is a matrix, and then replace true, number of row equal to 6. Okay, number of row equal to 6. And then they have mentioned in here 1 to 10. So size 60, sample of size, and replacement to number of rows equal to 6. Now if you write in here mat1, you will get this. This is a 6 rows and 10 columns. Okay, 6 rows and 10 columns has been created. After creating this, now if we want to apply in this matrix, let me explain what does apply mean. Okay, take a look at this. This is the matrix that we created. It has a total sample size of 60. And then this 60 will come 10 numbers, 0 to 10 or 1 to 10. These are the numbers coming in here, and replacement to number of rows equal to 6. After number of rows equal to 6, I want to find apply mat 1. Mat means this matrix. I want to apply 1 means by row. This 1 means by row. If I put here 2, that means apply on this function on that column. If it is 2, this function will be applied by the column. If there is a 1, this function will be applied by the row. Understand? 1 means what? 2 means column. Okay. So I'm applying this function on that matrix by row. Do you understand the meaning of this? I am applying this entire function on that matrix by row. Why? I want to see in this row sum x greater equal to 4. So for example, in this one, I want to find the greater equal to 4. This is greater than 4. 1, 2, 3, 4, 5, 6, 7, 8. Are you seeing 8?
Yeah.
Now come here. This is the fifth one, right? 1, 2, 3, 4. Are you seeing 4? You understand? So in this case, if you have a data, and in that data, if you want to find how many people, if one, suppose there are first person, second person, third person, fourth person, like 100% is in there, okay? And their genomic data is in there, okay? And nowadays, like the medical doctor was when the genome project was established in 1990s. During that time, millions of dollars was given, okay? All human bodies that have all types of genes, we will discover, we will identify them, and then once it will be identified, then we will go for the personalized medicine. Personalized medicine means you might can take higher dose compared to I. You understand? So personalized medicine. They during that time genome project 90s. So now they come up with almost 100,000 different kinds of genome. So in this case, genome, if you want to find that if each of this row, how many exceeds a certain number, then this code you can use. So what we are going to use here, applying this function on this matrix by row in order to count how many elements exceed 4. Understand? So if this is the number of patients, you want to find how many of them has a white blood cell count greater than 70. Then you have to use these things. Okay, so you can find that well. So as this is the person, okay, this is the person. So this could be like sample, like the first sample of different person, second sample of different person, third sample of different persons, right? And then you can say that, well, for we conducted this R code on like 1,000 samples of different persons, their genome counts or some of these things. We found that like on an average, like and then if you find the average, you can find that on an average we got that one, minimum we got this, maximum we got that. That way you can do this type of things. Okay, the way the materials was prepared, this is the materials that I have been teaching for the last 10 years almost. Okay, so when I was first teaching, I was preparing all the things. I was thinking when I did my PhD, what type of problem I can set up. So how can we do all of these things? By keeping those things, these materials was prepared and created. And when I submitted these materials to run a workshop in American Statistical Associations, they highly appreciated this. And then the highest number of attendance. I ran a short course of 4 hours and highest number of attendance. The topic was side-by-side learning of R and Python programming. The things that I'm doing, how can I do same thing by using Python? Okay. Highest number, and then American Statistical Association was super happy. They made a lot of money and they also give me some. Okay, they also give me some and they waive my, I think, registration fee. Anyway, I am writing it in my CV and people know that I know all of these things. Okay, anyway, after doing these things, now next one is what? Next one is which row contains exactly 2 occurrence of the number 7. Okay, exactly 2 occurrence. How can we do that? This could be done like this again. So apply mat1 function x sum exactly 2 occurrences. Exactly 2 occurrences of 7 is appearing only one time. So take a look at that. That is the first one. This one, none of these rows has exactly 2 occurrences of 7. Right? Only first row has, right? Only first row has. Can you find exactly 2 occurrences of 8, right? So that should be row number 3. Let me change it to 8. Three. Are you seeing? So row number 3. Row number 3 has 2 occurrences, right? If I want to find this, like, let me see which one has exactly 3 occurrences. Okay. 10 is appearing 3 times in row number 4, right? 10. So let me check it. I want to put it 3 and to change it to 10. 4. Are you seeing 4? 10 is appearing 3 times in row number 4. Okay. Remember, a lot of very good code of R are provided together with a very beautifully and simple way in a document. The documents, what documents? That is a very simple way written, right? And code is written also. So it has been provided to you. So it will be a valuable things for you. Okay, now let me go to the last one. Last one is this one. Anyone in this classroom took calculus class? No, right? So I see your face. She's saying no. Very, what it called? You do not know that level of math, like. So some kind of. Anyway, the integration is sum. You know the 4 operator, right? Addition, subtraction, division, multiplication. Multiplication is kind of addition, right? And division is kind of subtraction. You know that, right? So in calculus, there are 2 things which are opposite. One called differentiation, and another is called integration. Differentiation is the change of rate, and integration is the sum. Okay. So one is subtraction, one is addition. So there is a NP formula between them. There is a formula to connect them. One is the NP of the other, like America and Russia, right? So derivative and integration and derivations, they are NP. So the final question 30 that is saying integrate x square plus ex. So I want to find the area of this function between 2 to 10. Okay, between 2 to 10, I want to find. More specifically, if someone asks me, suppose this functions looks like this. Here is x. Here is fx. Here is like this, and it is 2, and it is 10. Okay. Sorry. It is 2, it is 10. Okay. I want to find this area. How much area is in there? Okay. And this is the function. This is the function of x square plus e to the power x. This is the function, and I want to find this area. How can I find this area? This is known as the integration x square plus ex. Suppose this is the curve of x square plus ex. How can I do that? This is just, I have to write the function. I have to write the function. And after writing the function, if I integrate this, then I'll get the results. So this is the results. Okay. 22,344.74 with absolute error is this. So there could have some error. That error is this. I have 10 minutes remaining. I'm just want to introduce one thing, but I will discuss these things next class more deeply. Are you seeing? Suppose this is my where should I go? I should go there, and all USM, and then fall 25. This is my face-to-face class. This is week 2 to 4. And this is my data, class practice data. CSB data. Very big data, okay? Very big data. So next class, you are going to learn first, how can I import these data in R? In this data, are you seeing ID is the variable, and then race is the variable, income is the variable, age is a variable. In this way, there are 25 variables, okay? Now I want to import these data in the R. Understand? This is a CSV data, comma separated value, CSV. How can I import this?
I'm trying to put it like in a similar, like folder in the same file location so that when you program into R, you can call on the file.
Good. So this is the data. See how big the data is. It has 20,900 rows, okay? 20,900 rows it has, and it has altogether 25 column y up until a to y equal to 25, right? 25. So let me show you how to improve this, how to import these things. So this is the location where my file is, okay? My file is on this location, okay? I right click on there and I go to the properties, and then I copy the location that gentleman said. What is your name? Okay, he said these things. I just copy these things. I just copy the location of the data, okay? And then I come to the R, and here is the place I paste it, okay? After pasting it, I put the forward slash. What is the difference between forward slash and backward slash? So let me tell you, this is the slash. It started in backward and moved forward. And this is started forward and moved backward, okay? So I think this one is called forward slash, right? Or this one is called forward slash. This one is called forward, right? Or that one? Come on. So, okay, you are confused. You are confusing me also. Okay, I was okay before starting discussion on that. Okay, let me show you. You have to make this type of slash in here. But when you copy and paste, see the, are you seeing this is the, when you copy and paste, you will see this type of slash, but you have to change it to this type of slash, okay? And after doing this, at the end, this is the location, and at the end of the location you have to put another slash, and then you have to declare the name of the data, class practice data. This is the name of the data, class practice data, right? And the data is in the CSV format. Are you seeing Microsoft comma separated value? Are you seeing Microsoft comma separated value? Microsoft Excel comma separated value. CSV you have to write. Now, what is Excel? What is the difference between Excel and CSV? Excel sheet can hold up to 1 million data points. After that, you cannot see those things. But CSV, it can hold 10 million, 100 million, something like that. CSV, comma separated. Okay. The few talented people who are sitting in the top places, they are doing all the work for the rest of the world. And most of us do not know how the touch phone works, right? We do not know. There's so many things we have learned today, but someone else developed the code inside. The way we are writing sum, the sum, someone else is put it in there in the format of a package. That is where we are getting the loop that we run, nested loop, loop within loop. Someone else already did all of those things. Okay, super talented people. We are just learning. Okay, after doing this and after running these things, then if you hit this, control enter, your data is in there. Okay, my data is in there. So this is the things. Control Z. I need to get rid of that. So my data is this one, D1. D1 is my data. How can you see that? If you want to see the D1 is the data, take a look at that. Okay, hold on. Hold on. If I want to show you head, D1, this is the data. Now we will learn all of the 80 problems from this data. How to sort the data, how to arrange the data, how to put the data so that the name of the variable can be alphabetically ordered. All of these things we will learn. Okay. So I will provide you this code. I will provide you this code and everything. Already I provide you the code for the today's lecture, but this thing, like now you are going to learn how to do the data analysis. There will be 80 programs. Next class, I will go little faster. Okay. The next two class, I will finish your project things. And then from the fifth class, I will start doing probability. And after finishing probability, then I will go test of hypothesis. That's the, but I will have a lot of time. Only concern is that we are missing two classes, one for the fall break, another one for the Thanksgiving. Okay, I will make a request from the next year. I should not be given on Thursday because of missing two classes. That means I cannot teach, I cannot do upload any materials on this. Okay, I'm going to stop in here. Okay. So we have 2 more minutes, but I'm going to stop in here. So let me see. Stop sharing. And then stop recording.